Okay, hello. We're gonna go into question 7 now, which asks, explain how to calculate the velocity from a distance time graph. So how I'm just gonna do one as an example. Okay, imagine that's a straight line. Actually, let's not imagine so much, a bit like that. And imagine that our this is gonna be our distance and this is time, and we have something like that, and then maybe here it goes like that flat, and then maybe here it goes up really steep, and then here and then down like that. So how do you calculate imagine that this is 1 minute, and this is 2 minutes, and this is 3 minutes, and this is 4 minutes. And if this normally this is in seconds, or doesn't matter really, in minutes, it's alright. And then distance here we'll do it in meters, and let's say that this is 10 meters, and this is 20 meters, and this is 30, this is 40 meters. So something like that, and then so how do we calculate the velocity from this graph? Well, you have to calculate the velocity how do we so I'll write it here. Do we calculate velocity from the distance versus time graph? Well, we're saying in the previous video that the gradient, sort of the a rise in the distance away from a fixed point here, this is our origin, a rise in the distance away from this origin means in certain amount of time means you have a speed, right? Because the distance is changing in an amount of time. So another way of saying that is if there is a big inclination, it means that there is a big change in distance in this amount of time, whilst this could be 1 minute and this could be 10 meters. But if there is a little inclination, then within also 1 minute, so the same thickness as here, then only that inclination means that there's a smaller, this could be only 3 meters maybe, less change in the distance for the same amount of time. So therefore this would be a big gradient or inclination, and that implies a large amount of distance in a short amount, in the same amount of time. It would imply a high velocity, high speed. Here we don't care so much about direction, and here we have a less steep one, so that's less distance in the same amount of time, so it's a smaller gradient, and that is equal to a lower speed. Okay, so in other words, how do we calculate the velocity from a distance time graph? You just need to calculate, or you can also measure it if it's an accurate graph, or measure the gradients. So the inclination or the gradient of a distance time graph is what's going to give you the velocity here. So this would be a slow positive velocity, or slow speed. This would be zero inclination. There's no inclination here, it's not going up at all, it's just flat, so that would be zero speed. Here would be fast speed, because look how much it's increasing, like 20 meters or 15 meters in half a second, so that's a very fast speed. And here again that would be zero speed. And here the inclination is even bigger than here, so actually even though the distance is getting smaller and smaller, it's actually coming back towards me. So here it's coming towards the origin, so if here we call it positive because it's going away, then here it's negative speed in the sense that it's coming back towards me, but the actual magnitude, the size of the speed is bigger than this one, so it's even fastest speed. Alright, so hopefully that makes sense, that the gradient is related to this. And yeah, and the only other thing to say here is that if the gradient was here, they're all straight lines, so these are constant. That's a constant slow speed, constant fast speed, constant zero speed, obviously zero speed, constant. The fastest speed here is also a constant because they're straight lines, but the moment you get curves like that or like that, then this would be accelerations, right? So in this one, let's have a look at each one. In this one, if the curve looked like that, then the gradient here is quite shallow, right? Imagine you're trying to climb this with a bicycle. Here it's quite easy, so that means a small acceleration. Sorry, small velocity. I don't know why I did that. Let me just go back. Here the gradient, which represents the velocity, we just said that the gradient represents the velocity, so here there's a small gradient, so it means there's a small velocity. Here there is a much bigger gradient, so here there's a large velocity or large speed. Let's use the same words all the time because I'm changing from one to the other and they're slightly different, but here we're talking about speeds for now. And so small speed and then larger speed, so here there is an acceleration, right? It's going from smaller speed to going quicker, so this is an acceleration. If you had a curve like that on a distance time graph, right? But if the graph looked like this, distance time graph, if the graph looks like that, then initially you have a really big gradient, so you have a large gradient which is equal to a large speed, and here you have a much less steep gradient, so that's a smaller speed, right? Until eventually this could even get flat, and if it gets flat, then the gradient would be 0, and so the speed would be 0. Right, so if it goes from a larger speed to a smaller speed, then there's a deceleration or a negative acceleration. It's the same thing, or negative acceleration. Okay, so a curve like that is constant positive speed, and this is on a distance time graph. That's this would be away from the origin. This would be constant speed towards the origin, towards whoever's measuring it. This would be an acceleration, and that would be sorry, that would be an acceleration, and this would be a deceleration because it's going quickly and then less quick. So if we had it going downwards, which is a little bit more confusing, but we can still understand it in terms of gradients. If our graph looked like distance and time, and one of our graphs maybe could look like that, and then another one could look like that, then let's think about what these mean. Well, we just have to think about the gradients at the beginning and the gradient at the end, right? And then we know what's happening to the velocity. Here the gradient is very big, even though it's negative and it's going down. The gradient is big because it's a large inclination. If you were going down on a bicycle down this hill, you would go super fast at the beginning, and then down here you'd have a chance to slow down maybe. So this would be a fast velocity, speed. I keep changing my words, sorry. Velocity is also you can also use velocity here, but just going to stick with the same word, the fastest speed. And here's a slower speed. So whenever you're going from fast speed to slow speed, that means negative acceleration. okay, or deceleration, same thing. And here it's going from a shallow gradient, so like a slow speed, to a really fast speed. There's much more gradient there to a fast one, so therefore this would be an acceleration. Okay, and it would be an acceleration towards me. That's what it means, that it's going down. The shape is going down means that the distance away from me, and I'm here in the origin, then it's getting smaller, so it's coming over towards me, but it's actually speeding up towards me. That's why the gradient is getting bigger and bigger. In less time it's changing more, the distance. Okay, so hopefully that makes sense. These guys are both coming towards me, and one of them is slowing down, the other one is speeding up. These are going away from me, this one is speeding up and this one's slowing down, and these are going at a constant speed. One of them is going at a constant speed away from me because the distance is increasing, and the other one is going at a constant speed towards me because the distance is decreasing. Okay, so hopefully that all makes sense, and that was all related with question 7. So in the next video we're going to talk about the velocity time graph, which they're making us draw instead of a distance time graph. But before we go, I'll just do a quick summary, putting them all in one same graph and seeing if we can interpret this properly. So let's see if we have a distance time graph here. We make it big and nice and big. Actually, we'll make it bigger, like that. What happens if our bad mistake not to label this is really bad for a teacher? That needs to be labeled time. Okay, and so let's draw something. What could it be doing? It could start like that. I keep having a really bad pulse, I'm sorry. Okay, it could start like that. Then it could go like that, for example, and then maybe like that. Then here flat, and then like this, and then maybe flat, and then like that. It's never gonna go backwards in time, so that last line needs to be corrected so it looks a bit like that. Okay, so just quickly, what would these mean? So let's see if we can analyze these properly. Well, in the first one, what's happening to the distance? First of all, I need to know what this axis is. It means distance. In the first part, what's happening to the distance is completely a constant. Okay, so if this was here 20 meters, it's staying at 20 meters. So from here to here at this time, and this could be 1 minute, for example, there is zero gradient. Zero gradient, so zero speed. Here it's increasing, but at a constant, it's a line, straight line, so it's a constant speed. It's constant speed. Okay, away from me, because the distance is increasing and I am here measuring the distance with respect to me. So it's constant speed away from origin. Right? This is constant speed, also straight line, but towards. Constant speed towards. This now is a flat line again, so that's zero speed. This is now a curve and it's going away from me, so that's going to be positive because it's increasing. Here the gradient is low and here it's bigger, so it's increasing speed. So an increasing speed, which is here lower gradient and here higher gradient, that means positive acceleration, and it's moving away from me, away from origin. Here it's flat again, so that's zero speed. And then the very last part, it starts with a very low gradient, so it starts with a very low inclination and gets bigger and bigger and bigger until it's a pretty fast speed. So here it's away from me and it's getting closer to me. So it's, first of all, it's going at zero speed, then it starts speeding up because the gradient starts getting bigger until it's very big gradient. So in other words, it starts away from me stationary and it starts coming towards me as the distance gets smaller, right? Because the distance is getting smaller here towards me, even though that this looks like a big distance, that's just the time that's gone by. So what matters is this value here, and the value here is very small, so it's close to me, so it's towards me